Hey, new video. This one's going to be really awesome. It's an amazing looking function that I saw online, and I'm going to be breaking it down and showing how it works. So we've got this awesome, crazy looking function. As you can see here, we've got this huge string of nothing but symbols, no letters, no characters. Well, there are characters. The only thing that is a number is at the very end, and that's the number that we're calling. And what this does is it's actually a binary decimal converter. So if we drop in 18, that's really hard to see. But sure enough, you got 16 and 2. It does convert 18 into binary. So we're going to break out of here. Now, I saw this on Quora from some guy named Sam Torso. Credit goes to him. Let's start out first of all with a simple binary to decimal to binary function that you can read in plain English that doesn't take a lot of explaining. So here's what it's going to look like. We're going to keep a string, which is going to be our answer, and at the very end we're going to return our answer. In the middle we're going to start out with a simple for loop. Set our variable I, and over here we're going to divide it by 2, drop the remainder. Alright, here we go. And in the meat, we're going to want to set b equal to our iterator modulo 2 plus b at the end. And in the meat, we're moduloing it and appending that to the front of b. Alright, so let's start trying to simplify this and break it down. Like our goal is to get rid of a bunch of as many numbers and characters as possible. So let's start out here at the tail end of the for loop. Well, I can see immediately math.floor, that's not going to fly. We're going to want to replace that with something more concise. Now, there's an operator that lets you shift bits. It's essentially taking the binary representation of I and shifting that right one time. So for example, if I have something like 101, well, shifting that over to the right and dropping the far right digit, I end up with something like 10. And so you're getting 5 and you're ending up with 2. So, and that kind of makes sense because everything being shifted down 1 means you're dividing every little component by 2 and you're dropping off the far end. So that's why it works. And of course, we can also make it apply to I, simplify that just a little bit more like that. Easy as pie. Another thing I want to tackle is this right down here. We can make this a slight bit prettier. And the way that we do that, or it's rather more complicated, but it looks prettier in my eyes, is by anding by 1. So what does that do? We're essentially taking the modulo of I by 2. And to prove that to you, well, think about it like this. Anytime you have to take the modulo from a power of 2, like for example, you want to take the binary representation of that. Well, we've got 8, 4, and 1, which is equal to 13. And we've also got 1, 1, 1, 0, 0, 0. There we go, 8. If we take this and subtract 1 from it, well, now it's suddenly easy to take the bottom 3, the last 3, which is what we're doing when we're moduloing. We're essentially taking the last 3 digits of the binary conversion. If we AND these together, then what we end up with is our desired result, the last 3 digits up here. And that's kind of what they do in subnet masking, if you're familiar with that. And we get our answer. So you can actually do this more and experiment with it yourself, and you'll find out that it really does work, and I'm not just lying. Alright, another step I want to take is getting rid of this line. I don't like it. Bye. And the way that we do that is we can make an optional parameter and declare b up here. So what it's doing is it's basically saying, if I call it and I didn't pass in b, then set b equal to blank string. But if I do pass something in, then set it to whatever I passed in. It's just a default parameter, basically. So what I could do instead is I could start off with d to b if I'm converting 10, and then pass in stringy something. Then b would start out as string. But if I don't pass anything in, like I did at the very beginning, then it's just going to assume that it's equal to a blank string. This is the part I've been dreading. We're going to turn this into a recursive function. Oh no! Yeah, it's not that fun. But in the end, it will look a lot prettier, so it's going to be 100% worth it. In the end, we're going to want to kill the for loop. But first, we're going to alter the return call by calling our function again. And in our first parameter, what we're going to pass into d is going to be d but shifted over, aka d divided by 2. And what we're going to pass into b is d modulo 2, the same thing as d and 1 as we determined earlier. Then we're going to append it to our answer string b. Alright, now our return condition, our kickout condition, our exit call, is going to be not d, because with truthiness, if d ends up being 0, then it's going to kick if into high gear, and then we're going to know that we can exit with b and get out of our recursive call. And with that, I think it's safe to delete our lovely for function. Goodbye. So one more thing that I want to show off is the ternary operator, which it exists in most programming languages, but essentially with ternary you can have a condition, a question mark, and given if the condition is true, then it's going to return the first expression, and if not, it's going to return the second expression after a colon. And this is just syntactic sugar. It's kind of like a if-else. So what we're going to do here is try to implement that in our return statement. So how about instead of all of that, return, alright, let's take our condition, just d, question mark. If we want d to be true, what's going to be returned? Well, we want to return this junk right here because it missed b. So let's type that in. I'm going to space this out a little bit more. Don't need to compact it just yet. Make it hard on you guys. Alright, now if we want it to be false, then it's going to return b. Nice, so we've condensed these two lines into one. Okay, there's one more thing on my hit list. I want to show you arrow functions, and they exist in other languages, but I especially love them in JavaScript. They really just look nice and are an overall improvement. They're kind of like inline functions, and what they do is you take a parameter list, and there are many variations, but essentially you can just return your answer like that. And that would be the equivalent of defining something like function and then return answer. This is much more concise, and you put your parameters in here, of course. So let's try to experiment with that and see if we can replace this function. So remember in JavaScript that functions are first-class citizens, so we can actually write the above in the anonymous function form, kind of like this. And it's going to be the exact same thing. Now, using what we just learned about arrow notation, well, let's see here. We're going to put our parameters in the parameter list. And after the arrow comes what we're going to return. Well, what we're going to return is this garbage up here. I could copy and paste that, but I'm not feeling confident today. Alright, here we go. So we've effectively just reduced all of that into one line. Nice. But I'm still not entirely satisfied. I mean, you still got a bunch of characters in there and numbers, so let's actually target the numbers first. In JavaScript, our goal that we want is to replace all the numbers and characters with just symbols. Well, JavaScript has a bunch of weird ways of doing that using type coercion. First of all, you can start out with an empty array, and it's going to give you an empty array. But if you put a Boolean not operator in front of it, what it's going to do is it's going to force whatever comes after it to become a Boolean value. So as you can see, this is actually false because an empty array is something. It exists. Even if it's empty, it's still sitting there. It's still an actual item. And in JavaScript world, that means it exists, but we just knocked it down, so now it's false. We can turn it back into true using not. Another cool thing is unary operator plus, and plus is really good for our purposes of converting things like booleans into numbers. For example, if you have true plus true, it thinks that's 1 plus 1, or true plus false, 1 plus 0. And the plus sign, you can even use it as a unary operator to turn things from Boolean into a number. So plus bang bang empty array gives you 1. And you can even do this on primitive types. It's actually quite interesting. So knowing all that, let's go ahead and replace the 1 in here with that information. So I'm going to come in here, replace that with plus, replace that with plus bang bang close, and replace this guy with plus bang bang and close. Nice, I like that. Another thing, when you add up two empty arrays, you actually get an empty string. And if you play around with this, you kind of see why. In JavaScript, they're like kind of like zippers. So we're just going to toy around right here. No. Right, see, it kind of zips everything up into a nice little string. So knowing that, let's go ahead and replace this. I'm picky, I don't like empty strings. I'm just going to replace it with bracket plus bracket. Much better. Alright, we're almost done. What we're going to want to do next is replace the B and replace the D. Well, in JavaScript, $sign is a legitimate variable, and so is underscore, and so is any possible combination of that. And if you know JavaScript, if you know the jQuery library or the Lodash library, you already know that because that's what they use as their global variable as a part of the library. But we're going to go ahead and take advantage of that. First, let's replace all the D's with a $sign. Replace D with $sign. And let's replace all the B's with Lodash. Okay, $sign, $sign, $sign. Should use a little bit of Vim's keyboard. Alright, and Lodash, and Lodash. Not bad at all, if I do say so myself. Alright, D2B. Like I said, you can convert it into underscores and $signs. So let's take that. Let's delete it. Nope. Oops, I screwed that up. Underscore $sign. Hey, that looks pretty good. I like it. Alright, now let's delete all the spaces. Get rid of you. X. Get rid of you. Oh, I like it. I feel so happy after doing this. I mean, this is awesome. Alright, and we're gonna also want to wrap it in parentheses so we can call the function from anywhere. Just modularize it. Alright, I think it looks identical to the one above. Hopefully it didn't screw anything up. And we're gonna pass in as a parameter for, I don't know, 4, 5. I don't know. So let's go ahead and run this thing. Oops, that was anticlimactic. Alright, what did I say, 45? Okay, so that'd be 1 plus 4 plus 8 plus 32. Yep, I think that's 45.